the problem is scarcity more so than it is cost. So the challenge that these folks actually have is complete projects in time and complete them with the people that they have, because there aren't that many people in the first place who do this job very well. I think actually one of the interesting misconceptions is that AI is very good at doing engineering work, right? In science fiction, AI is traditionally something where, let's say, creativity and thought processes that are akin to humans only come last, or rather is the pinnacle of what AI is supposed to do. So as you know, AI actually and machine learning can reach the level of, creating, decent poetry way before they can actually deal with, drug design or again, engineering work, right? So,
hey everyone, and welcome to the Bricks and Bytes podcast, where we dive into construction and AEC technology. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode. I recently came across this company 4M Analytics, and after taking some time to understand what they do, it felt like the kind of company that ticks all the boxes of great technology in the AEC and public infrastructure space, such as simple technology with instant value and outcomes, a great founding team, a strong reputation across the industry based on conversations we've had with other stakeholders. If you've ever tried putting together utility records, you'll know how painful it is. Outdated PDFs and unreliable, conflicting information from 10 different sources. It's slow, messy, and risky. 4M flips that on its head. It's basically Google Maps for above and below ground utilities. You punch in a location and boom, you get reliable utility data you can trust and verify in one easy-to-use platform. AI does the heavy lifting, but it's backed by real human verification. Big players like Mastech, Kimley Horn, TX. C. and utility owners are already using it to cut down weeks of back and forth, speed up planning, and reduce risk early on so they can build better together. If you're working on infrastructure projects or projects which require super fast, detailed utility records, I would highly recommend checking out 4manalytics.com.
Francesco, thank you for finally joining us. I think we discussed Augmenta maybe, I would say 3 or 4 months ago now on Bricks, and Bytes, which is another podcast that we do. And it sparked a few debates, should we say, amongst some of the peers in the industry. So we're glad to finally have you on and be able to hear from the man himself and what you guys are finally, or what you guys are have been up to over the last few months or so. So yeah, thanks for coming.
It's really appreciated. Thanks for having me on. It's a pleasure being here.
Cool. I'm also just going to say one thing. I've just done it already, but for some reason I'm struggling to get my words out today. So if I say something and it just makes no sense, then hopefully you can remind me that I've just done that.
It's all good.
Cool. All right, let's do this. So Francesco, actually, to kick this off, I did tell you we were going to go into a little bit about your background, but can you just give us a little bit of like an overview where we are in terms of generative design in the AEC space? Like, what's the current sentiment? What are you seeing? Like, what are you thinking, etc.?
Yeah, I mean, as you know, generative design has been around a lot, right? So in architecture, especially in architecture among all kind of AEC, right? So, but its roots are or have been kind of very firmly in shape design, in conceptual design, massing, right? So in test fits, right? So there has been a fair amount of use of generative design in the very kind of early stages of the process, and I think that it's being, and it still is actually kind of very, very successful there, right? And so the people actually do regularly use a variety of tools to explore the space of shapes, if you will, right? So it's been an incredibly kind of powerful tool, since the early day, when Robert H actually kind of introduced, generative components in Bentley, has been kind of a progression, right? So through Rhino, Grasshopper, various other tools, Dynamo, and then of course, many other tools that have emerged in the last few years, right? So that make this, more and more a very real, very kind of explorable option. I think that as of late, there is just more opportunity to take it kind of further, if you will, right? So there's more acceptance of generative processes in general, right? So being more pervasive, right? So I think that, the generative design and the combination of generative AI and generative design are gaining some momentum as they appear to be working properly, if you will, right? So from very early on, as I said, right? So very early on stages, actually, when people are only using it in exploratory kind of scenarios, right? So I think they're actually going to go, or they're actually gaining more popularity progressively as they become more and more capable, right? So downstream, if you will. And I don't see actually a lot of resistance actually to it either, right? So which is good. It's probably going to be a byproduct of people being very kind of overwhelmed with the tasks at hand, right? So having generative processes to help at least explore, right? So it's it seems to be a welcome thing.
Is that because with like the advent of AI, these things have become more straightforward to use? That's become more. I guess the keyword you used was capable. So yeah, does that relate?
Yeah, I think so. I think capability. I mean, let's say two ways, right? So one is precisely what you said, right? So they're more accessible, right? So the fact that some of these tools and some of the kind of latest machine learning capabilities allow for very straightforward conversation, if you will, with technology, right? So with these agents, right? So it certainly helps kind of lower the barrier, right? Generative design, if you think about it, traditionally has been kind of the domain of folks who wanted to get their hands dirty, right? So if not scripting or programming themselves, right? So with visual programming tools, but people need to want to tinker actually quite heavily, if you will, right? So to actually get the best out of them, right? So whereas there's definitely been a trend to lower again the barrier to accessibility, and certainly the wave of large language models and essentially interfaces that are more conversational, that where the expression of the intent can be kind of managed by a very kind of savvy partner, if you will, on the other side of the screen, right? So it certainly actually helped for sure. So on the other hand, the capability is also essentially on the outcomes, right? So essentially kind of what the tools are capable of actually providing, of delivering, how deep they can go, right? So how much work they actually take on, what's the percentage of your workflow, if you will, that they can intervene on or automate entirely in some cases.
Okay, very cool. All right, let's rewind a little bit before we go to. It's very tempting to like dive into that straight away, but it would be good to hear your background, because Augmenta has been going now for 6 years, which is
Yes.
like that's a good time. Yeah.
Oh, yes.
But before that, you were involved with Autodesk quite heavily as correct the title wrong, director of computational design, is it?
Research. Yeah, that's right.
Yeah. So
That's
just
right.
talk to us about that journey. How did this all come around?
No, absolutely. So, I mean, I've been interested and intrigued by 3D computer graphics actually for the longest time, right? So, I mean, I started my career in video games, right? So in games development, like many years ago, my first career, right? So, but that led me to approach essentially every problem that I would encounter, in my career as a software engineer, with an eye towards optimization, towards performance, right? So towards kind of scalability, towards getting everything you could out of the platforms, right? So, and that led me eventually after a few years, like 9 years in games, right? So to join Silicon Graphics, which was at the time kind of one of the like heavyweights in kind of large scale compute and large scale visualization, and so I kind of cut my teeth in like problems that are like big computational problems, like fluid simulation for like oil and gas, rivers, reservoir modeling, or modeling ocean currents, right? So, or large scale kind of financial markets. So I moved actually from SGI to IBM Research, where I worked on very large computer systems, right? And so the so-called Blue Gene program. So that was actually really interesting. It gave me a perspective on yet larger affordances that like colossal computer systems could tackle, right? So it's quite uncanny the types of problems that you can solve when you have that much computational firepower, if you will, right? So and then Autodesk, right? So at Autodesk, the reason why I was hired in the first place was that there was a shift in platforms, right? So from desktop to cloud, right? So and Autodesk wanted to be kind of firmly one of the kind of early shift adopters, if you will, right? So I wanted to promote that very heavily. And so my experience in high performance computing helped me to have a perspective on how to use the cloud in a creative manner, if you will, not just for storage or collaboration, right? So for a data repository or just for like a multi-user kind of workflows, but to actually leverage this kind of newly cheap or cheaper computational power that anyone could access, right? And so the concept of that became called kind of generative design kind of started there, right? So where essentially I just realized that for some types of problems, like the ones that I experienced before, humans aren't very well equipped to solve them kind of on and on, right? So of course, human race has geniuses, but it's hard to have them available on a whim for anything you want to do, right? So that's really kind of what actually prompted me to actually go deeper in automated design, and again we can talk about it more. But that actually kind of led me to essentially start and pursue, right? So the entire generative design initiative at Autodesk, and then essentially that led me to Augmenta kind of more recently, right?
Very cool story. So you were very technical in your background, and
Yes.
you have a technical background, now building a very technical product, and you're the CEO of Augmenta. So yeah, how was it like stepping from a role at Autodesk, which I'm guessing it was like quite steady and you know what you were doing and like you're heading the team and whatever else, to going into something like uh, where the world is your oyster almost.
No, for sure. It's definitely a leap, right? So I've worked in corporate environments for many years, right? So for me, it was certainly a bit of a shock, right? So, but um, I wanted to try my luck in a way that would be unrestricted, if you will, right? So, like in large corporations, you have a substantial advantage of having kind of your back kind of covered, if you will, right? So you have lots of resources, you have affordances, right? So on the other hand, of course, you have to adhere, if you will, right? So to corporate policies and the overall trajectory, right? of the corporation, which makes perfect sense, right? So, and I felt that at some point, my desire to innovate in the AEC space actually was larger than the brakes, if you will, that I had on the trajectory, if you will, to get there. Right? So I thought that at that point of my career, right? So I had kind of one chance to say, okay, well, let's try this. Let's try this myself, with the help of good trusted friends, right? And see how it goes, right? So, but yes, absolutely, it is very different. Like in a startup, especially, right? So you have to deal with everything. It's kind of back to basics, if you will, right? So there's no downtime. There's no stop thinking about things. Or it's always a rush. It's always on, right? So that's actually very different, right? But I love it, actually. It's very interesting. It's a very different thing, right? So it's a lot more stress. But the satisfaction that you get when something actually works out and people are satisfied of the results only because of a trajectory that you and kind of your close partners actually have started or have envisioned, right? So is priceless, right? So it's actually
Yeah,
priceless.
very nice. Okay, so what did you like? How did you identify the need then for Augmenta? And yeah, let's start there, and then we'll go on to how like it's evolved from day one to what it is, where it is now.
Oh, certainly. I think the need, the need for generative design became apparent very early on, right? So after kind of joining Autodesk, right? So I understood, as I was saying earlier, right? So that there are some tasks where large-scale computer systems are just inherently better, right? So, and it doesn't have to be necessarily about creativity, but about exploring a space of opportunities, a space of designs, if you will, right? In the broad that kind of sense. And after working for 7-8 years in the manufacturing side of generative design, I came in contact with AEC, like as part of being at Autodesk. Essentially, you almost cannot avoid it, right? So and it's so pervasive actually in the firm, right? So and it's great, right? So it's very nice actually to have that possibility to see, right? So to see and analyze things actually that deeply, right? And then I realized actually very quickly that the construction, well, AC overall, but certainly the engineering and construction kind of worlds desperately need generative, or rather desperately need help
here
from digital tools, right? So it's just that like as in the gap between, let's say, the potential and the state of the art and the the current workflows, right? So it's so big that it was actually a lot bigger than in almost any other field that I could see, right, kind of properly. And so that essentially made it very clear to me that that something had to be done. And I just analyzed my circumstance, and I decided I couldn't do it fast enough. And that's where. So again, the need was very apparent, in my opinion, right? So I didn't invent the need. Essentially, like what I wanted to do was approach the need differently from before. Well, with automation first, with the artificial intelligence and automation first.
Interesting. So yeah, what if you could tell us maybe like what's the best way to do this? Augmentor is now let's go with where Augmentor started, because
Yes.
I know you guys, spoiler alert everyone, focus on electrical design, but was it always that way?
Yes, actually it has been always that way. So it was a combination of market analysis and pure coincidence, right? So again, sometimes you're lucky, sometimes you're not, right? So in this circumstance, again, like we found a partner very early on, right? So that had a vested interest in developing automation capabilities for electrical design, right? So, and while we were looking for the best place to start, right? So, and we documented ourselves actually on where to apply essentially generative principles to AEC, right? So we thought it was like a perfect fit, right? So like a really strong fit. The reason being that it's very underserved, right? So as a kind of field overall, not just MEP. I mean, MEP is underserved by itself, but electrical in particular, right? So it's very underserved, while actually being very much on the critical path, right? So electricians are the last folks in an MEP process, at least in general, right? To receive early coordination drawings, and then they have to rush to model everything that they can as fast as they can to meet other folks at coordination, and then move on from there, right? So we thought that it was a disservice, if you will, right? So and so that could be our the first point to apply pressure to, if you will, right? So it turned out that we made the right and wrong choice in the sense that it's the right choice in the sense that again it's very promising, and that the pain is extremely real, right? So the pain of modeling BIM systems actually at the level of detail that is required for prefabrication, right? So for actual fabrication of site, right? So is very, very hard, right? So it's very much a pain. So it is very much an opportunity, but on the other hand, it's extremely hard in terms of putting it as a task for a computer to solve, right? So and regardless almost of the methods. So, but yeah, we started directly with electrical. We thought we would be able to move into MEP faster than we actually did, right? So, and we're still electrical to this day, right? So given like the sheer complexity of doing it well, right? So
No, I was
That's
going to
still
say,
our trajectory.
yeah, why is electrical so complicated? Right?
Yeah, no, it's a really good question, right? So there are two aspects to this, right? So one aspect is just high level kind of regulatory compliance, like the rules, both the written and unwritten rules, right? So for electrical systems are very quirky, if you will. They're very complicated from the standpoint of their reach, if you will. Like some of them have some of them influence designs in a very kind of physical, kind of geometric kind of way, very visible kind of way, right? So, and some others are actually much more subtle, but influence the design in other avenues that make it very difficult computationally to solve for, right? So to essentially to design for. Right? So on one hand, essentially getting a strong and full understanding of the rules and regulations and the best practices, and on the other, again, the learning from the field, right? So learning from experience of like the professional trades folks who have done this actually for decades, right? So that know how it's done within the framework of the rules and regulations, right? So they know how to do it best, and it's not really written anywhere.
Yeah.
Right. So there's a component of it that you can approach systematically, and another that you have to approach in a much more holistic way. Right?
Sounds very common actually. The builders take the drawings and go, yeah,
that's
we
right.
know how to do it.
I know, that's right. I mean, it's it's something that still exists to this day, right? So if you think about it, like BIM teams many times actually contend with field teams, right? So where at the end of the day, the field wins, right? So the field personnel actually changes, or has the power to change BIM designs, because even very proficient BIM designers sometimes don't have the experience of a master electrician, right? And so there's this back and forth that makes it really tricky to codify, if you will, right? So the best practices, right? So on the other hand, it's like a purely geometric issue, right? So as in, especially raceways that are common here in North America that are made of, metal sticks, conduits called, right? So the sheer volume and amount of them, right? So makes the design problem like very, very difficult. Like as in, we regularly see buildings from small schools to all the way to data centers, and the more complex ones have tens of miles of raceway sprawling around from a multitude of electrical rooms intersecting with each other, being multi-layered racks of these pipes that spider around.
You see them,
and like a person can immediately spot something that looks off, or that's not so again, having a computer deal with designs of the size, right? So in a way that kind of looks and feels and makes for a correct design is very difficult. It's actually very difficult.
It sounds complicated, because it's kind of like it makes sense in the way of building a good startup, right? You go very, very narrow. But like in construction, we're not just talking about like a trade. We're talking about very specific things within that trade. So my question would be, you mentioned there raceway. Like when you first started, did you really focus on like one particular element of that entire electrical schematic, should we say, versus like going for electrical, because that's like a very broad term, really?
No, for sure. So again, look, we tried to pick our battles, right? So I mean, of course, you go in a startup, right, as enthusiastically as you can, right? So you try to conquer the world, right?
Yeah,
right?
easy
right away, right? So and then you actually have to start, to pick your battles. So let's say that at the start, we started essentially the journey with let's say a broader purview than what our first product actually kind of turned out to be, right? So our first kind of foray essentially included many characteristics of electrical systems that in the end we aren't shipping yet in the product, right? So but that we designed the product to cater to eventually, right? So when we are kind of confident that we have a high degree of success, if you will, in that portion of the workflow. But yes, we did kind of focus on a specific subset if you will, of the electrical trades. By all means, like tackling it all at once actually would be very difficult, right? So we tried to actually design the system so that it wouldn't kind of paint us in a corner, right? So in a way that we could then proceed to other portions of the trade. But yes, like our choice essentially has been since the very beginning to focus initially on North America, on the most widely and most common type of electrical distribution system in the US and in Canada, essentially North America overall, which is this overhead conduit structures, which again it turned out to be kind of good and bad, as in good as in there is a lot of need for this because it's very hard, it's very time consuming, very tedious, right? So, but on the other hand, it is also probably the hardest computational design problem there is out there, right? So, thank God. I mean, eventually, it works now, right? So, but yeah, it took a lot of blood, sweat, and tears. So
yeah, that's interesting. So, who was like an ideal customer for Augmenta? Let's start with it, and then I'll ask.
Yeah. In North America, there is a very peculiar separation or distinction, if you will, between engineers and subcontractors, right? So there is the separation of responsibilities is slightly different than in Europe, right? So over here, engineers that design electrical systems actually do so at the very, very high level. So they're very coarse grained, right? So they give indications, they give high level guidance, right? So, but they hardly ever model in BIM, in the BIM sense, right? So much of the electrical system. So what happens is that the subcontractors that are the folks who actually have to design BIM, the BIM models, and then manufacture or procure and install, right? So they're kind of on their own, right? So they have to equip themselves with digital talent and processes to create fully constructible designs and coordinated actually with the other trades, right? So and then again for the purpose of having as much offsite manufacturing as they can get, right? So to reduce the cost and the time, and then for having the highest possible success in the field, right? So when they assemble actually these systems. So our immediate target, if you will, right? So our ideal kind of customer right now is one of these electrical subcontractors here in North America, right? So that again have this task, right? So they're heavily kind of involved, or actually their input is essential actually in the definition of the electrical raceways, from the perspective of the manufacturing and installation of them, design, manufacturing, and installation of them.
Okay, interesting. So you mentioned subcontractor, trade contractors, electrical trade contractors primarily,
That's
right? So how it works is they would receive a design. In here in the UK, we call it like intent or like performance specification or something like that. From I don't know if you're familiar with that term.
Yes.
Yeah.
The terminology is actually very similar, right? So over here as well, right? So it's that here they take like maybe specific forms, like one-line diagrams or early coordination drawings, right? So that also have specifications actually written, kind of generally like kind of large PDFs or that include like all the circuiting and all the requirements, if you will.
Fine. And so then Augmenta would then take this and generate. I hope you like the term. Into like a constructible design from there. Is it that simple? Am I oversimplifying?
I mean, let's say that's the end goal, right? So we want to let's say automate literally end to end, right? So what it means to actually ingest those requirements and specifications and then output something that is a one click, fabricate or procure, if you will, right? So it is not quite as streamlined today, right? So what our system actually performs today is it does in fact actually take those specifications and the architectural structural building model, right? So and it performs again to your point, right? So the full routing and generation of these raceways across the building, right? So in one shot, right? So in a way that it is ready for coordination at the very least, right? So is not ready for procurement simply because, well, there's a number of reasons, but one is because coordination then actually takes multiple iterations, right? So we work with design environments, in this case Revit, right? So where people have the ability to again intake a design generated by our AI and then modify them at will, right? So they can change them around if they don't like a portion. Actually, we support the fastest way for people to edit and complete, if you will, their designs, right? So and then push it downstream. So, but we do the heavy lifting, if you will, right? So we do essentially the work that teams of BIM designers actually today perform manually, right? So for the most part, right? So they take this intent, to your point, right? So and sometimes they got these schematic diagrams, if you will, and turn them into a BIM model, right? So a BIM model that is fully routed, is coordinated, right? So it respects a variety of rule sets and constraints, right? So it shouldn't look like a mess, if you will.
Okay, fine. So it does the heavy lifting, and then there is a human required at the end point to like just fine tune to
Yes.
a fully coordinated constructible design, right?
That's correct. So right now, essentially, let's say that the output is maybe 80%, 85% there, right? So and then people are still actually necessary, right? So to finish it off, to complete the task. Yes.
Do you think it'd ever get to a point where it'd be 100% accurate?
I think so. I mean, it's a matter of time and willingness to invest, right? So we're seeing we measure a particular our kind of main kind of KPI, right? Our main kind of score really is how much time people spend on using the system kind of overall, right? So versus relative to the amount of time that they would manually modeling everything, right? So and essentially our path, our trajectory is to make it zero, right? So to essentially reduce progressively the amount of tweaks, the amount of intervention, right? So that they need to have, right? So over time, the system is learning to actually do better and better, right? So we tweak the machine learning systems and the more kind of systematic placement of parts, right? So in a way that there's fewer and fewer interventions actually needed in the design output. So yeah, the idea is to actually get to zero. Will we ever get there? Over time, for sure. It's just it depends on the workflow, right? So it could be diminishing returns.
And with your solution, I can't think of any other way to word this, but maybe you'll have a better way of explaining. But would your solution replace people that typically do this, or something else?
No, it's a great question, right? So I know it's rightly provocative. It makes perfect sense, right? So as in, no, I mean, but it makes total sense, right? So let's say that since the very beginning, when we started actually going down this path, right? So it was made clear to us that the problem is scarcity more so than it is cost. So the challenge that these folks actually have is complete projects in time and complete them with the people that they have, because there aren't that many people in the first place who do this job very well. I mean, the ones that do are really excellent, and by all means, right? So, but the demand for electrical design, outstrips the available resources, the available capacity, actually by quite a bit, right? So, and it's not getting any better, right? So the problem of labor shortage is very real, right? So, and not just in the actual construction site, right? So, but schools aren't kind of producing, right, and trades aren't producing enough people, right? So, kind of worldwide, but especially so here in North America, and so the goal has always been to assist, right? So to assist these folks actually with tools that allow them to do more exploratory, more conceptual work, right? So in a guidance and in a command and control kind of fashion, rather than getting rid of them altogether, right? So there's still, honestly, there's no replacement for the expertise of these folks. That is extremely unique. Essentially, kind of what we're aiming to do is to give these people a team of more junior designers each, right? So
Mhm.
that's really kind of how you can think about it, right? So they become, orchestrators of a group of virtual designers, right? So that can do a lot more value engineering, that can do a more detailed job, if you will, right? So that can explore, options, for example, right? So we're trying to actually shoot for value add and for schedule compression rather than, replacing, the people that do this today.
Yeah, it's an interesting point. It's very, very good answer actually, because I don't know, people seem to always be hiring for electrical engineers. I'm like, wow, if you're an electrical engineer, you could probably demand a pretty decent salary these days.
That's right.
um, okay, how about the funding journey then? Did you were you funded? I think you maybe bootstrapped in the early days, but then the reason we spoke about it as well because there was large news of you guys raising it around. So yeah, if you could talk about how you funded this and like what were the investors looking at, and what made them convicted that Augmentor is going to hit rocket scale?
So the conviction is different. Let me kind of roll back kind of first, right? So just as you said, we bootstrapped ourselves, right? So by doing very custom development, right? So to assemble the team and to make sure that we were on the right kind of track. And then when we hit like a basic, let's say, proof of concept, right? So we went out actually and sought funding because it's inordinately expensive to develop software of this kind. That's the reality, right? So that's unfortunately the reality that most AEC startups actually face, right? So building, professional tools is exceedingly long, right? It takes a long time. I mean, of course, the more complex the software, the more expensive, right? So, but there's always demand for something more. Right?
Didn't
So
someone? Yeah, just to interrupt. So your point
yeah.
about how expensive it is to develop AEC. Someone
Oh
was
yeah.
telling me last week you were at NXT Build, right? And I think someone there
Yes.
said that in order to recreate Revit, it would cost something like over 350 million. That at least their calculations like in the 300
I
and
think there
something
was
million.
more like 500.
500, yeah, exactly.
Yeah,
You're probably right.
yeah,
So
yeah. I'm not shocked in the least, right? So
yeah.
as in, it really does take, a considerable effort, and not the funding scenario, right? So and options aren't always, the most rosy actually for a journey of that kind, right? So
Mhm.
let's say that, the way we approached it has always been, again, that we are not trying to recreate Revit. We're not actually trying to recreate any modelers, right? So we took an approach that has always put full automation kind of first, right? So it's not a workflow accelerator, if you will, right? So we always kind of took the side of the how do we automate this end to end, and then kind of start with that, maybe cut it down into something that is manageable, and then expand from there, right? So, but it's never been, let's say, a simple, a route, one piece of conduit from here to here, and then you're on your own, right? So it's literally on the path of getting essentially full results in a single shot, right? So with minimal commands, and of course, the more context you provide, and the higher the likelihood that the AI will create something that you can picture in your head ahead of time, right? So, but that's really kind of the prerogative, and that is, I think, actually the reason why we've been successful in funding, right? So, as in the trajectory that we're on, right? So, is one where we will approach more and more of the problem of construction design, right? So, from this perspective of design automation first and design tweaks or design edit last, right? Or next, if you will, right? So in this sense, we're not really in a red ocean, right? So, and that actually is appealing, well, to us, of course, right? So, but also to our investors, right? So there is really a prerogative for us that that really kind of connotates us as a slightly different type of AC startup, right? So, and that has been kind of successful actually for us. On the other hand, there is the concept of which it was actually the foundation of our latest round, right? So, of our stance on sustainability, right? So, as in, we truly believe that is only by virtue of automation that scarcity in good design can be overcome, right? So it's literally the only way to make essentially efficient design available to all buildings and not only to the ones that can afford to have engineers, perform a full site analysis, full performance of work, and full, considerations for, types of HVAC systems, you name it, right? So as in, there's only so much that you can do with a given budget, right? So, and we are not interested in making the tip of the spear, billions of dollars, building yet more efficient, because they can already afford, huge engineering teams, etc. Right? So we want to make all the remaining 99.999% of buildings right across the planet just as performant, right? So that there should be no excuse, if you will, right? So when we're done, for buildings actually not to be the best they can. That's really kind of what is compelling in having an automation first approach, right?
100%
This actually becomes
agree.
real by default, if you will.
Yeah, I really like this argument actually a lot. It's something I hadn't actually thought about until you mentioned it, but I know from personal experience when you see like some of the cost of these systems to make buildings more sustainable, like it's the first line item on any project that gets slashed because people are like, well, we can't afford it. But that's not the best choice when you think about like what humanity really needs: better buildings and a more climate efficient environment to live in. So this is like a very strong point, I think, about Augmenta.
It's literally about again, scarcity versus plentifulness, right? So, and throughout human history, scarcity has been tackled by automation. That's the reality, right? So something only becomes plentiful and affordable when it's at scale, and scale in most human endeavors has been accomplished, at least in the recent centuries, right? So by some forms of automation, and that's really kind of what we believe is essential. It's essential.
Very good. Okay, how about integration of a product like Augmenta? I'm just looking on my screen here at some of the more technical questions, and I'm
Yes.
not going to lie to you. This is like a little bit above my pay grade, so I'll go with an easy one, and then an easier one, and then maybe we can dive into some more technical stuff. So yeah, Francesco, if you could tell me, like, yeah, how important is it when you're building a solution in the AEC space? Like, how does it need to integrate with something like Autodesk? But then also, what maybe is interesting is, by integrating into a system like that, are you, I don't want to say competing, because perhaps they don't have a point solution to what you're doing that is as good as what you're doing. But I'm guessing with like Autodesk Push and their design and make system right now, that there is some form of like drive for them to want to get more involved in this space.
No, I couldn't agree more. But I mean, to be honest, again, it's something that we learned very early on is that you need to be respectful, right? So, as in, this is an industry that rejects folks that come from left field and try to teach how it's done, and for a good reason, right? So it's very peculiar. I mean, I've only been involved in the construction industry for the last maybe 7-8 years, right? So and I'm still learning everything, right? So it's, you have to, I mean, in my opinion, you have to come in a way that has kind of strong sense for how people work, for what people are actually trying to accomplish, right? So because at the end of the day, it's all about the goal, right? So what people are actually trying to achieve, right? So for me, integration is natural, as in it's necessary to respectfully meet people where they are, right? So they have hard deadlines. Again, the AC industry is extremely hectic, like constantly late, constantly over budget, and again, there are things that are completely out of people's control, right? So that can make it so as well. This is not just the tool's fault or people's fault, right? So it's just a mix of incidents, right? So we actually consider integration kind of just a necessary part, right? So it's not even a necessary evil. It's actually a way in, right? And so that's why with the market analysis, actually, it was very easy for us to understand it. We'd have to integrate, with Revit in this case, right? So because that's where the industry is here in North America, right? So the workflow that these electrical design folks actually is 99.9% in Revit. So for us, it was a no-brainer to actually do an integration, right? So on the other hand, we we made the decision also very early on, which also, cost a lot of, blood, sweat, and tears. It still does, right? So to craft a platform separate from Revit, right? So we decided not to build on top of one of the existing platforms, right? So we integrate with it, but we are essentially an external kind of entity that lives in the cloud, right? So that technically has the ability to integrate with anything else, right? So, but of course, the integration actually with Revit is very, very natural and very successful. As in, again, we have come to meet where the industry workflows are today.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
Mm-hmm. Cool. Something that we discussed when we spoke about Augmentor is about this notion of error-free designs. Can you explain, what does it mean? What does the error-free designs mean, actually?
That's a very, very good question. Very loaded too. So I can tell you that error-free design is not what we generate today, right? So let me start from there. Mm-hmm. So that's actually what we aim to produce, of course, right? So it like over time, right? So, but error-free actually for me is mostly a matter of seamless integration with the design workflow in a way that people recognize a design that is created by our AI as something that is akin to what they would have created, right? So that would be like an amazing kind of stepping stone to kind of full error free. So error free technically means something where you can take a BIM model that has been output, right? So by a system, right? So and procure it verbatim, right? So the output is a bill of materials, right? So you have the ability to order it like as is, right? So and then you're guaranteed that it is compliant, that it'll fit together, that all the parts and pieces that you need are accounted for, right? So that's the trajectory, that's the ultimate goal, right? That's the ultimate vision, right? So we're getting there in increments, right? So we're moving through the stages to actually make it so, right? And right now, again, there's still need for human intervention, right? So it does not actually create error-free design, right? So, but we're getting closer and closer. Then again, we see and we track, we measure that proximity, if you will, over time, right? So, and we can see that it's regularly, like a steadily, essentially, getting higher and higher. The level of quality, we call it, the precision, if you will, right? So it's increasing all the time.
Mm-hmm, mm-hmm. Very good. And maybe something to think about here might be about. So in the world of electrical, you obviously have things like raceways, as you call them. I think the UK, the British, it's English, British, whatever you want to say, is conduit, perhaps. I think maybe you mentioned that word as well. But this is like almost very like standard sizes, standard sections, and so on and so forth that you get. But when you're dealing with manufacturer specific components within electrical systems, how does something like Augmentor work with that concept, perhaps?
No, that's a very good question. So going back to what I was actually saying earlier, right? So we designed the system to work with as close as possible to reality entities, right? So what we wanted to do was, and still is, is to build agents that understand the physicality of the components that they're manipulating, right? So right now, again, what we generate is, let's say, rather generic, if you will, right? So it's something that is a very kind of strong guidance for design, right? So it's a fully, accomplished kind of BIM model, right? So, but it's not made of parts and pieces that come from a catalog, if you will, right? So they're actually kind of quite, they're standard parts, if you will, that you can swap in with others by all means, right? So, but the goal, as you correctly mentioned, is also deal with manufacturer specific objects and entities, right? So, and again, the system underneath is actually designed to deal with them, right? So essentially, it's designed to create full raceway componentry, right? So from essentially a given bag of parts, if you will, right? From a catalog of objects, of real objects, right? So their digital manifestation, if you will, right? So in that sense, actually, again, it's something that we are not exposing to our customers actually as of yet, because we want the quality of the designs that we produce to be closer to perfection, right? So before we essentially created these systems already from the manufacturer's parts, right? So, and not these kind of generic entities, if you will. But we're getting there, right? So essentially over time, there'll be a threshold, right? So I'm thinking actually sometime actually next year, right? So where we can, let's say, activate this characteristic of the system that is already built in the design of the platform, right? So that can actually output like essentially an actual bill of materials, right? So that in fact actually contains manufacturer-specific, information and designs essentially the raceway systems actually with them. By raceway, I actually mean kind of a high-level concept of electricity transport mechanisms, if you will, right? They could be, cable trays or baskets or, kind of dock banks underground, right? So conduit as well. So it's kind of a high level. Right now, we only deal with conduit and EMT, right? So, but again, the roadmap actually has all the other forms of raceway, right? So in there.
That makes sense. Thanks for clearing that one.
Of course.
Okay. How will AI disrupt the generative design space? Bold predictions. Oh, what do you already know?
Well, I mean, I'm very much an optimist actually here, right? So, I mean, I guess by nature, right? So, but I think that over time, it will take more and more of a prominent place, right? So again, people not only kind of want optionality, but they want to ultimately reduce the risks, right? And so, as I said earlier, right? So automation is the only it's truly the only way to mitigate that risk, to actually have more information available to people earlier on, right? So upon which actually to make decisions, right? And so I have, again, a rosy expectations, right? So from technology actually moving forward, not only, again, machine learning is moving by leaps and bounds, right? So but again, we see it every day. Our own system actually is maturing, daily, right? So I have very high expectations, actually, in fact, right? I have high expectations, so high, in fact, that I believe that over time, this affordance will, if not force, will, let's say, push the industry to rethink some of the way they, write contracts, or some of the way, projects are insured. Like, as in, I think it'll have a very pervasive effect, essentially, on how the industry actually kind of works, how the various stakeholders in the industry actually work together, right? So the transparency and the promptness, right? So with which this information will become available, detailed design information, right? So will be available, right? So it's in my opinion, is actually destined to change the behavior of the industry actually quite a bit.
Interesting. How about like some misconceptions of AI? Like, obviously we're in a major hype bubble right now, and people are claiming like every industry is doomed and blah 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 blah. What's your views?
I mean, it's I think actually one of the interesting misconceptions is that AI is very good at doing engineering work, right? So which is, like, as in, if you think about it, like, as in science fiction, AI is traditionally something where, let's say, creativity and thought processes that are akin to humans only come last, or rather is the pinnacle of what AI is supposed to do. Like, after it has kind of solved everything else that there is to do, like, any form of scientific and engineering kind of work, right? So where precision and rigor and mathematics, if you will, are involved, right? So which is, in turn, actually turns out not to be the case at all, right? So as AI actually and machine learning kind of reached the level of creating decent poetry way before they can actually deal with drug design, or you know what I mean, or again engineering work, right? So that, I think, is actually a misconception. The fact that the affordances of large language models actually make it look so simple to have near human thought, right? So make people conclude or project that therefore anything a human can do after even years and years of training, now essentially the AI can do by default, right? So whereas that is so not the case, right? So it's very, very much not the case, right? So I'll leave it at that, right? So there's much to say in that sense. The capabilities will increase, of course, right? So but we're far from that moment.
No, yeah, very grounded response. Okay, maybe a few more questions here as looking at the time. How do you get in front of electrical subcontractors to like put this under their nose, let them use it? Like how do you sell to your customers? Like, what's the recipe here?
So the recipe is really to appeal to the pain that they see, right? So again, we're not teaching them anything new about their job. It is just about kind of showing them that we realize just as well as they do that there is a problem, right? So, and that we have a solution to that problem, or we have at least a plausible solution to that problem, right? Sort of partial and plausible solution to that problem. So again, luckily, let's say we're not a solution in search of a problem, right? So our problem, if there's any, right? So is really not to identify the pain, right? So the pain is already very clear and present, right? So our value proposition is very straightforward, right? So now essentially our prerogative is to make sure that people try it and realize that it works, right? So and the word kind of spreads, right? So right now, honestly, let's say folks who are naturally early adopters that are open to trying things that are bleeding edge, right? So are being successful, right, with our system, right? So with our technology, right? So it takes a while for testimonials to emerge, for projects to complete, for things to go really well, right? So we're very eager actually for that moment, of course, right? So we have already kind of some success that we can talk about, of course, right? So but the more the word spreads, right? So and the better it will be.
Yeah, I guess it has to take like a natural progression here, because you can't force it onto people, right? Like people literally do need to touch and feel it and think, yeah, they like it, then word will spread. But how?
I don't. Yeah.
I suppose maybe the question is like, how do you? How do you actually get in front of them in the first place? Is it like an outbound effort for now? Are you more like focusing on a select group? How's that work?
We have a variety of means, right? So we definitely use outbound, right? So it's let's say a mix of outbound and inbound, right? So we do actually get contacts on our website actually from firms who have seen us present at an event,
nice.
Or I've heard from some of their colleagues that work in another company that are maybe trialing, or that have seen it, or that have watched a podcast, right? So or a webcast. So essentially, we're trying on one hand essentially to make sure that people at least know that we exist, right? So and the type of pain that we solve or that we address, right? So and on the other hand, again, we participate to events to make sure that the word kind of spreads, if you will, right? So we're not trying to explode our sales. Like, so we're trying to actually be very intentional in following very, very hands-on every customer, right? So as again, it's our first prerogative, being the first into market with a solution of this kind, right? So you have to make sure that the workflow actually does what it says, that customers are productive and happy. And so again, we're intentionally kind of focusing, let's say, on a subset of the entire kind of market first, right? So, and then progressively kind of ramping that up, right? So, but we have our own BIM team in house, right? So to make sure that connection is very, very deep, right? So with our customers, right? So our we call them application engineers, right? So they are people with 20, 30 years of electrical design experience. They've been BIM managers that have built data centers, etc. So they know the pain and they know how our technology can alleviate that pain very, very well. And so it's a conversation that happens, right? So it's not just a sale. And that's actually this worked actually well for us. So far.
Yeah, that's pretty awesome. Very curious to just thought about this when you're answering. Like, who are the people demographic wise that approach you from an inbound basis. Maybe the leading part of this would be: do you find that it's typically a younger generation in the AE space? Certainly, something I've noticed is you have a lot of like communities within the AEC sector, and they're typically run by a younger demographic. So I'm just very curious as to like who are the ones that approach you and like, oh, we want to use your solution.
I think that there's some differences, right? So, as in generally speaking, we talk to BIM managers, BIM leads, VDC leads, sometimes CIOs, right? So that have a vision, right? So for their organization, right? So I think that let's say a portion of the inbounds are from younger folks actually who are kind of naturally open to understanding the affordances of what's out there, right? So what's bleeding edge, right? So, but I still actually would say that the vast majority is people who have been in that position for a while, for a few years, that understand that scalability has reached its limits in terms of, kind of how many people you can throw at the problem and the challenges of the insane schedules that they're actually working against. And so they're just, it's really kind of a cry for help, right? So from people actually who have been, in this business actually for a while, which is interesting. Like you would think that, it's only the younger generations that would be attracted actually to AI.
Yeah.
The thing is, honestly, we hardly ever mention AI, right? So the fact that our system is an AI, right? So it's entirely secondary to what it does.
Yep.
Right. So again, we're kind of very pragmatic. We're trying to help these people actually get to their goals faster or in a more, detailed, kind of better, more valuable way. Right. So how it's done, it's kind of irrelevant. Right. So, and if that's not the case, right? So, but if we had, and if we had trained, a bunch of I don't know, robots or humans actually to do the work, 5 times as fast, and that was a service, that would work too, right? So, luckily, it's not the case, as in it wouldn't scale, right? So we do have an AI, in fact, actually. But at the end of the day, right? So these folks actually, it's only there's some interest in being at the bleeding edge, right? So of leveraging actually the best the technology can actually afford, right? So, but on the other hand, it's just the harsh reality of getting stuff done faster, right? So when people are kind of persistently late before they even start, right? So that makes the demographic, if you will, less biased towards the younger generations in our case, right? So the pain is so acute that it's the people who feel it most, right? So, generally, it's the people with pain who feel the most. So
yeah, very good. You make a great point about the AI. I always say to people, no one really cares about AI; they just want to get their job done.
100%.
Yeah. But one thing I have noticed is people may actually start caring about like whether you are like a native AI, like something like Augmenta, right? You was like 6-7 years old versus something that's just come out of like an AI app building app in the last year that it probably doesn't stand too much of a chance against some of the monolithic companies within the AEC space. To that then, Francesco, do you see Augmenta evolving? Last question, by the way. Into something like much grander, like is electrical the stopping point? You mentioned mechanical like earlier, so maybe there's a hint there. But do we go even further than that?
That is definitely the vision, right? So we won't kind of back down, right? So as I said, we want all buildings to be sustainable and to be efficient, right? So and to be built, economically, right? So to be more affordable, right? So, and we truly believe that the automation, like deep automation, is the only way. So electrical is really the tip of the iceberg, right? So the next stage will be MEP, right? So MEP, which includes, coordination, right? So essentially creating not only kind of BIM models that are kind of fabrication ready, right? So, but coordinated with each other, right? So, which is a huge, huge problem actually right now in this industry. Even actually using, the latest and greatest, BIM tools, people have to toil away for weeks or months in coordination meetings, having, oh no, the duct has a priority. Oh no, this actually goes to a wall. So that's what I mean. Like, as in, we're attacking the problem bottom up instead of top down. That's why we are unique in that sense, right? So we're starting from constructability, right? So, and then moving upstream, right? So we're moving upstream in the sense of abstracting the requirements that our generative system deals with, right? So right now is the requirements are the requirements of electrical engineer, and the output is, a constructible BIM model, right? So then going upstream, the requirements will be the ones of a mechanical engineer, the ones of a plumbing engineer, that are the ones from a structural engineer, upstream, right? So then eventually the ones of an architect, right? So we want to expand the platform into encompassing more, it's certainly of the functional portion of a building, right? So everything that actually makes it, work and perform, right? So MEP first and then structure, right? And that's a trajectory.
Very good. Like a lot. Thanks, Francesco. Can you tell people where they could find out more about you, Augmenta? Are there any initiatives that you have going on right now? Are you hiring, etc., etc.? It's your time to plug. Plug away.
Excellent. No. So of course, everyone actually can look us up actually on our website, augmenta.ai, right? You can also kind of follow us on our LinkedIn kind of page, right? So we regularly update essentially our the events that we follow or where we speak, right? It's all kind of very kind of public there, right? So then, yes, you can also come and see us actually at one of the events, right? So we regularly kind of post at the events that we participate to on our LinkedIn page, right? So it'll be just stop by and have a chat.
Awesome. Thank you, Francesco. And yeah, speak soon. Yeah.
Absolutely, a pleasure.